Hello everybody! These are our video solutions to Quiz 6, Spring 2023, Math 302 at Cal State Fullerton. This is problem 1, and there's only going to be 2 problems on this quiz, and they are all about modular arithmetic. So this first one is just a straightforward computation. We're going to find the least positive residue of 2023 to the 2023rd power plus 20 times 23, and we're all going to reduce this modulo 8. And it's important here, right? What do we want to we're reducing it modulo 8, but to what? And the answer is I want the least positive residue. Okay, so this means that I'm looking for something in so my answer should be in the set 0, 1, 2, 3, 4, 5, 6, 7. And remember, 0 is not really positive, but we're going back to the way Gauss writes stuff, so 0 is in there. Okay, let's break this down. First thing, when you are reducing an arithmetic expression, so something which has got pluses and times in it, and you're going to reduce that modulo, well, some modulus, you can do it term by term. So for example, when you have 20 by 23, I can reduce the 20 modulo 8. And what is 20 modulo 8? Well, one quick way to see this, right, just keep subtracting 8s until you get down into this set. Okay, I could subtract 2 8s, that would be 16, and that would give me 4. And I can do the same thing with 23. I could subtract 2 8s, that's again 16, and that would end up giving me 7. Okay, and then I can multiply these together, right? So 4 by 7 is 28. And then I can reduce that modulo 8. So in this case, I could subtract 3 8s. That would be 24, and that leaves me with a 4. Now, another thing you could do at this step when we got to 4 by 7, well, the 7, even though I want everything to be a least positive residue, that doesn't stop me from along the way using, say, a negative residue. And if I subtracted another 8 from 7, I would have ended up at negative 1. And maybe negative 1's a little bit easier, right? If I'd have had 4 by negative 1, I would end up with negative 4. And negative 4, well, that's not a least positive residue, but if I add 8 back to it, okay, so I'm going to add 8, I'll know I end up at 4. So I get the same answer as up above. Okay, now for this, it's not all that interesting. Like, yeah, doing 28 mod 8 really wasn't all that hard to do anyway. However, if we keep this in mind, we're going to see the other part of this problem will be made a lot simpler if we recall that 7 is congruent to negative 1 modulo 8. So we come over here. Now, one thing that a lot of people might mistakenly do is reduce both the 2023 as the base and the 2023 as the exponent. And that we're not allowed to do. The important thing here, right, this means 2023 times 2023 times 2023, 2023 times. So I can reduce 2023 modulo 8 in each of these 2023 instances, and then I'd multiply those together. That would not be the same thing in general as reducing this number of times modulo 8. We're just not allowed to do that. All right, and we can write down easy examples where it fails. So I just need to reduce 2023 modulo 8. And I'll tell you the way I did it, but you might find a lot of other approaches yourself. So the first thing I noticed was that 8 times 5 was equal to 40. And then if I took 40 times 5, this was equal to 200. Now you might say, well, why didn't you just multiply 8 by 25 in the first place? Well, I didn't think of that. Now, why am I trying to get up to 200? Well, because now if I take 200 by 10, I get 2,000. So I can multiply 8 by 5, and then by 5, and then by 10, and I'll get 2,000. Which means when I'm reducing 2023 modulo 8, I could subtract 2,000, and I get 23. So this tells me that 2023 is congruent to 23 modulo 8. Okay, now 23, well, that's that we actually already saw over here on the right-hand side. I could subtract 16, and that would give me a 7. But now I have to multiply 7 by itself 2,023 times. But what if I use this further congruence? What if I replace 7 by -1? Now I know that 2023 to the 2023rd power is congruent, modulo 8, to -1 to the 2023 power. And that's really easy to do. It's -1 to an odd number. This is just equal to -1. But of course I want the least positive residue, so now I'll convert it back to 7 modulo 8. All right, so in total we ended up with a 7 plus a 4. Or, I mean, look, I even could have kept it as a -1 plus a 4. That would have been great too, right? Because -1 plus 4 would be 3. Or if I do 7 plus 4, I get 11, but modulo 8 is also 3. And so there we go. There's our answer. So 2023 to the 23rd power plus 20 times 23 is congruent to 3 modulo 8. All right, we'll see you next time. More fun with 2023.